software engineers, you shouldn't go near any enterprise application or serious application without fully understanding what scalability is. Now, imagine you have an application that serves a few users, a couple of 50, 100, or even 1,000 users. Everything works fine. Now, what happens when traffic grows? What happens when you have to serve a million customers? Would the application still have the availability it had when it was serving a lower traffic, or would it crash? Now, the answer to this question revolves around the concept of scalability and how your application is adaptable, how it's able to handle increased traffic and still maintain its core functions without losing data, without losing customer trust, and the service level agreement that has been presented by the application. Now, the first and intuitive solution to this first problem would be to scale the web server. Now, to scale the web server or increase its ability or capability, we have two basic ways we can do that. We have the vertical scaling and the horizontal scaling. In vertical scaling, we are basically telling the web server, okay, take more hardware, we increase the RAM, we increase the CPU, and ask it to work harder than it's currently working. But the problem with this is that the RAM that we are increasing, the CPU abilities that we're increasing has a ceiling. And as this as we increase the hardware, the cost implication also increases, and this leads to a single point of failure in our application. If the web server goes down, regardless of the hardware abilities, everything else goes down. Now, the solution to this is the second and the very frequently used one, which is horizontal scaling. Now, in horizontal scaling, we have a situation whereby we have multiple instances of the web server running the same instance of the application, and we have a load balancer sitting in front of those web servers to distribute the traffic among those servers that we have. This is very optimal and widely used in the industry. Now, you'd ask yourself, how would the load balancer decide which web server should handle each request? Now, there are a couple of algorithms that we have currently to handle this. We have the round robin, we have the weighted round robin, and we have the list connection algorithms. Now, these different algorithms serve different purposes for different use cases. Now, one other thing we have to consider is if we have multiple instances of our applications, what we can have a situation whereby a user has a session data, maybe a login information, a login token that needs to be persisted during the time that the user is interacting with the service. How will the service know if a user used the web server one for to start with, and then subsequently it's routed to the second web server by the load balancer? How does this session get to be harmonized among all the servers? Now, this leads to the concept of sticky sessions or session affinity. Now, we need to have a way to make sure that each of these sessions or values that needs to be persisted is stored in a file system or a database that is accessible to all the servers that we have scaled horizontally. Now, by this, we have a situation whereby, regardless of the server that the load balancer directs the client request to, the server would also will be able to retrieve whatever session that he needs to perform the client requests and complete it duly without any hiccups. Now, that is a way to scale the web server. Now, you'd ask yourself, what about the database? Now, as we are scaling the database, as we are scaling the web server, we should also consider that the database is also a key component of our architecture. And as our servers are able to handle more requests, the database should also follow suit and handle more requests as we scale up and handle more user traffic in our application. Now, one of the concepts that we use in database scaling is replication. Now, replication is just the process of copying data to multiple instances of our database application and maintaining it as well. Now, this is very important and widely used, and there are two common approaches that we use in the industry. One of them is the master slave replication technique, where we have one master database we use for all write actions and then multiple slave databases that replicate from the master, and we use them basically for read operations. Now, For the master replication, we have a situation whereby you have you have two masters both accepting read and write operations without any segregation, and they both replicate from each other. Now, another concept that we consider while scaling an application is caching. Now, cache is a static random access memory kind of storage. It's basically faster than what we get from database or storage um, uh, other storage tools that we have. It's in like, we have the caching layer in front of the database to basically handle, be the first line of action to retrieve for fast retrieval of data that we did in our applications before moving subsequent requests to the database to for subsequent requests. Now, caching is very important, and there are a couple of um, concepts that we consider when implementing caching. One of them is cache invalidation. Now, cache invalidation is the question: how do we know when to caching layer or cached data still, and then go to the database to retrieve the data that we need? Now, this is a very key concept when we talk about caching, and we'll make some topics on that to discuss that further. Now, when we talk about scalability and everything that we talked about, we need to make sure that one of the key things that we need to make sure of while scaling is that we don't optimize or scale applications prematurely. Always start simple and then scale as needed. And one other thing is to always add redundancy at every layer of your applications. You add a redundancy in the servers, add a redundancy in the database layer, or even the caching layer. This helps you to prevent single points of failure in your application. Now, another thing is separation of concerns. Now, the web servers, the session stores, the databases, the caches, all should have distinct services.